Hello, this is Scott Denstead, Weather Systems Engineer and co-founder of WeatherSpork, your best online source for aviation weather and education. In this video, we're going to do a pre-flight planning session. Now, it's not going to be a complete session covering all the various different elements, but I want to basically be able to show you some of the features of WeatherSpork in your pre-flight planning. Now, I set up a route here from Savannah, Georgia, all the way through Myrtle Beach, Salisbury, Maryland, and up to Atlantic City. And we're not planning to fly today, but let's think about the trip for tomorrow. So today is Tuesday, March the 6th, and we're going to plan to fly sometime early in the morning on Wednesday, March the 7th. So this is our route, and this is our weather at the current time. Now, one of the first things I like to quickly look at is the Wheels Up Departure Advisor. And you can get to that from the bottom selection, and that will bring up a time slider that you can move from the current time into the future. And so I'm going to slide it along until about the time I want to depart, which is roughly 12 to 13 Z. So this immediately shows you that in this case there's going to be a fair amount of low IFR and IFR conditions along that route leaving tomorrow, at least in the morning. Now, if you want to postpone that flight a little bit longer, certainly the weather will improve along that route. So you can see that the Wheels Up Departure Advisor provides a pretty decent picture of the weather along the route. Now, see, if you were, in this case, a VFR pilot, maybe you didn't want to accept the possibility of having so much in the way of low IFR conditions along that route of flight. But maybe an IFR pilot wouldn't have so much of a problem. But we can see at a departure here at 1338 Zulu tomorrow. If you tap on any of these locations on the map, that will show you in this case that we're expecting a 300-foot ceiling and 10-mile visibility. So let's take a look at what's going on in this particular region to understand what hazards might be along that route of flight. Now, the first thing I would tend to look at is some of the weather imagery. And once again, we want to make sure we understand the big picture. So I'll go to the surface analysis and bring up the surface analysis with station models. And this gives me a good idea of all the major players for this particular flight. And all the observational data will start on the very far right, because that's the latest product that's available. And certainly you can go back in time by pressing and then dragging this and kind of seeing what's been happening over the last 24 hours. And what we notice is we have an occluded area of low pressure in the upper Mississippi Valley, and that's kind of just sitting and spinning. And an occluded system like that tells you that for the most part the upper level system is kind of stacked right over top of the surface-based system. But we do notice, if you look at the occluded and cold fronts that extend down into the Tennessee and Ohio valleys, you can see that with time, those do push forward. So we are getting an exchange of air mass. Now, another important thing that you'll notice is, and right around the northwest portion of Georgia, you see here an area of low pressure that's developed right along that front. So that will become important with respect to this particular weather system. So in order to understand what's happening over the next day or so, we're planning a flight tomorrow, we want to get a sense for how this is all going to evolve. And one of the best ways to look at that is through the prog charts. Now, since this is a forecast, you notice that the time starts in the very far left, because now we're going to be looking at what's going to happen in the future. This is valid at 18Z on Tuesday, and so if we move that time forward, what you'll notice is that by 6Z, the overnight hours, that area of low pressure that was in northwest Georgia is now starting to move more towards the coastline of North Carolina and Virginia. Very common for this to happen in these situations. So in these kind of situations, what we generally see is all the energy of this weather system tends to transfer to the coastal low, producing a nor'easter like you see here. So we can zoom in on this a little more to see the impact of that particular weather system. So in this case, mostly showing all over the northeast U.S. up into, from Maine all the way down into Pennsylvania, mostly a snow event. And it appears like a very high probability snow event. Any of the dark blue areas you see there are areas where you'll have a 55% or greater chance of snowfall. If we go back to 12Z on Wednesday, about the time we're going to depart, we notice that area of low pressure, which is in a strengthening state, most of that energy is being transferred to that area of low pressure, is just to the south of the Atlantic City area and certainly along our route of flight. That would add a fair amount of concern even outside of any significant wintry precipitation in that area. So this tells us at the big picture level that there's a major weather system intensifying. And we can look at some of the other details, such as the quantitative precipitation forecasts. And once again, we can move that forward to see what's going to be happening. In this case, we're looking at a QPF that's valid from 12Z to 18Z tomorrow, approximately the time we want to depart. And that again shows a fair amount of precipitation moving into the Atlantic City area. So this is a pretty intense area of weather that we know is developing, and that weather is coming off the Atlantic Ocean, wrapping around that area of low pressure at the surface. We don't want to forget upper level weather systems, because ultimately, if you look at just the surface-based guidance, you're going to miss the real big picture. In this case, let's look at the global forecast system. And I like to look at the 500 millibar chart, which is roughly 18,000 feet. This will also give us a pretty good understanding of kind of what's going on. So you remember that occluded low that was in the Mississippi Valley, the northern Mississippi Valley area? Well, you can see, as I said before, the upper level system is stacked right over top of it. It's a very distinct characteristic of an occluded weather system. Now, if we move this forward in time, and don't worry about the actual timing, what you're going to see is that weather system tends to wrap around and become a negatively tilted trough. Negatively tilted troughs do have some of the worst weather associated with them, so it's important to really understand that, again, this is a very intense system that's developing. So if we were to take and look at this negatively tilted trough and map that to our flight plan, we would notice that in this particular situation, let's take a look at the actual date and time. This is valid at 15Z, if you see at the very bottom here, 15Z on the 7th. In that case, that's exactly when we're planning to fly up this route. So in this case, we're going to find ourselves flying right into the jaws of this weather system. Not a good situation to be there, and probably one we want to wait until this weather system has moved out, and certainly that will be the case. You'll see that trough moves up into the coastline, and that leaves another weather system kind of lagging behind. So we can also look at other parameters, like the 700 millibar chart. Again, a great tool for most general aviation pilots. We tend to fly somewhere around the 10,000 foot range or even lower. So in this case, let's take a look at what's going to happen at that particular level. And we notice one thing that comes up in here. In this particular situation, we have again, a major weather system that's about to develop and push through our planned route. And so that's exactly what we see here. The red areas are what are called negative omega. That's vertical development. That's vertical motion in the atmosphere through the 10,000 foot mark. We see lots of that red showing on this particular chart. Well, that's again a good indication that we're dealing with a rapid intensification of this weather system, and again one we probably should be very careful about. And that tends to be right to the west. If we look at the date timestamp real quick, this happens to be right around 15Z. And you'll notice again that area of weather, that red area, is moving into the Harrisburg area, Lancaster area, and certainly is headed towards the coastline with time. So again, this is a weather system that could be very dangerous, producing some very intense weather, especially, let's say, along the latter third of our route. Now, speaking of that, we could also look at the route profile. So we've got our route plugged in here, and now we can see some of the finer details. Now, right now, I have all of the SIGMETs and GAIRMETs turned off to make this depiction much easier to see. Now, when you look at this, you look on the left side, you'll see Savannah at the very top left. and then it progresses all the way through to the right to Atlantic City. One of the parameters that you'll see on this particular presentation is the dashed blue line there around 9,000 feet. So that dashed blue line is the freezing level. And you can see as we go from Savannah, the freezing level is roughly around 9,000 feet right now. And essentially that goes down to around, somewhere around, let's go to this, 1,448 feet as we get closer to our destination. Now, of course, this is the current time right now. So let's look at what's going to happen in the near future based on our planned departure. So if we go over to about 13Z or so, we take a look at what's happening. What we can see in this particular case is a not so impressive area of clouds. Certainly the freezing level has come down all the way from Savannah, which has come down to about 4,000 feet or so, and that stays that way and even increases a little bit as you get closer to Atlantic City. So certainly at Atlantic City, we're dealing with a 5,400 or so freezing level by the time we get there. There are clouds, these white areas that you see on this particular diagram, there are clouds there, and certainly the clouds are somewhere around 13,000 feet at the tops once you get over moving basically in from the Virginia into the Maryland area in this particular case, and are much, much lower, not too deep at this point, but much lower, producing low IFR conditions, as you can see here for Atlantic City. So while it doesn't look a whole lot of threat at this point in time in terms of clouds, certainly as a VFR pilot, this would be a very tough and is certainly not a recommended flight. IFR pilot, on the other hand, would potentially have problems somewhere between when you cross over in from Virginia over into Delaware, up into New Jersey. That's where you're going to find the possibility of clouds that are at or below the freezing level. You can see that here. So we're dealing with a potential icing concern there as well. Now you could essentially look at this and fly over this point if you get up to, let's say, 14,000 feet or so and then descend down through. And once you get to your destination, you can see here that the freezing level is certainly going to be higher than the cloud coverage at Atlantic City. But what isn't really shown in this particular situation is the intensity of this weather system that's developed. Nothing on this shows the details of what kind of turbulence event this may pose. So there's not a lot of concern presented in this view, except the possibility of running into some icing, let's say at 9 or 10,000 feet along part of this particular route. And the other aspect is the low IFR conditions that you may find right at the destination. Now you could take your wheels up departure advisor and move that a little bit further in time and see that by the time we get to 18Z or 19Z or even 20Z, things are going to certainly improve over that period of time. So along your route of flight, you're going to see much more VFR conditions and little or no clouds. So in this particular case, if you are going to make this trip, it would benefit you to fly later. But I still would be very careful of this kind of weather system. We may see in this particular situation some very serious turbulence event as this weather system moves to the east, especially at the upper levels. When we see a negative tilted trough, this is an indication that this system has some teeth to it, so we definitely want to be careful. For the next day, I would wake up, look for any significant weather such as a SIGMET for turbulence. Most likely we'll see a SIGMET in this particular area, although you really can't tell that from this kind of view at this point in time. The other aspect in terms of making decisions for a timing event is to use the grid view. I really love this view. Again, it gives us the ability to see the route in terms of the threats along that route. And you have the same wheels up departure advisor, and as you move this forward, it gives you kind of a great indication of what's happening in this particular situation. And certainly by waiting, you can see that things tend to clear up nicely once you get into the afternoon time frame. So for this particular flight, leaving early is probably not a good option. Leaving later is definitely a better option from the clouds and visibility standpoint. but we still have that issue with respect to the possibility of running into some significant turbulence based on our view of the big picture. One other aspect of this is to look at the airport. So this is called a meteogram, which basically is the weather and how it's going to change at this particular airport. And I have Atlantic City set, and so you can see on the left side is basically the current time around 18Z, and then it moves forward in time all the way through 12Z on Friday to the right. So once again, we can look at what's happening in terms of our departure, and we see here that at 12Z at Atlantic City, it appears that we're going to be dealing with a low IFR situation. Freezing levels roughly around 3,000 feet. Freezing levels increasing as you go out through the day. Still low IFR, but by 21Z and then 0Z, we get a more VFR kind of conditions with less clouds. So you can see the period beginning as early as 3Z in the overnight hours all the way through till about maybe 21Z. We have some very low IFR conditions for that particular airport. So that concludes this video on how to use WeatherSpork in your pre-flight planning. Thanks for watching, and we'll talk to you again real soon.